All right, so here is the instructional YouTube video on exponential growth functions or growth equations, section 6.4, Algebra 1. Sorry, I got my dog Emma here squeaking her squeaker toy. I hope it doesn't bug you too much, but she's just having way too much fun for me to take it away from her. Emma, let's go quiet, okay, please? Just be quiet. All right, so first thing we're going to do is we're going to look at this problem here. Just a situation problem where we've got, you're 30 years old, been working at a job for a while, you've accumulated some money in your retirement savings, which is like a 401k type thing where, where you put your money into like a mutual fund type stuff. Someone else usually manages it for you. It gets interest based on, relatively safe investments. So you got $50,000 in a retirement fund. If the retirement fund makes 5% annual interest, how much money will be in the retirement fund when you retire at 65 years old, assuming that you don't put any more money into it? Realistically, you'd be putting money in every month with every paycheck. A little bit of non-tax dollars goes in there. But this is just to give you an idea of like how to set up one of these problems, and also the power of, or like how much difference it makes to put a little bit of money into retirement early on instead of trying to save up all at the end, because that 5% interest that you can hopefully get, not at a bank, but like in a retirement fund, that 5% interest, well, you'll just see what that $50,000 turns into. All right, so we're going to write our equation. Y equals, we're starting out with $50,000, and then what's going to happen is we're going to multiply it by something. Let's look at what happens here. Let's say I want, when I'm 31 years old, what I would do is I'd take this $50,000 and I'd multiply it by 0.05, because 5% is 5 over 100. Percent means per 100. So 5% is 5 over 100, which is 0.05. If I multiply 50,000 by 0.05, it's 2,500. Now that's what I would add on in a year. That's the amount that I would get in interest. So it's $52,500 that you'd have after 1 year. After 1 year making 5% interest. Okay, what we could do instead is we could just say $50,000 times 1.05. So really we have 1 plus 0.05. We're multiplying the 50,000 by 1 to get 50,000. We're multiplying the 50,000 by 0.05 to get that 2,500. But we're just adding them together inside the parentheses there. Let me turn these off so you don't have to look at that glare. Now, this is for 1 year. If I want to do this over and over and over again, I would continue multiplying by 1.05 over and over again. And when we continue multiplying over and over and over again by the same number, that's when we use an exponent. So the equation I would write is y equals 50,000 times 1.05 to the t, to the power of t. And let's talk about what this looks like in general for an exponential growth function. So in general, for an exponential growth function, let me get some different colors here. We're going to have y equals a, where a is the initial amount. And that means the starting amount, what we start with. So the 50,000 is what we started with. And then it's going to be 1 plus, and it's going to be 1 plus r, where r, this is the rate, the growth rate, as a decimal number. Which means it's the percent number divided by 100. And then t just represents the time. We've always got to have that exponent t up there to say, well, we're multiplying how many times. So here we go. We've got our 50,000 initial amount. 1 plus 0.05 gives us that 1.05. 0.05 because 5 divided by 100 equals 0.05. So we go 1 plus 0.05. That's where that 1.05 comes from. Right, so we're multiplying 50,000 by 1. That gives us 50,000. We're multiplying it by 0.05. That gives us 5% of 50,000. And then we add those together to get what we would have after adding in 5%. All right. Now, we want to answer the other part of the question, which is, how much money would you have from that 50 grand, when you're 65? So, at 65 years old, you've had it in your account for 35 years. It's been 35 years building on that interest. So basically what we're going to do is we're going to replace the exponent with the amount of time that's gone by. So we go 50,000 times 1.05 to the 35. So that exponent is a 35. So we just put that in our calculator. We go 1.05 to the 35. And we get $275,800 approximately. So it's about $275,800. It's like 877 or 800.77. There's like 77 cents. We can ignore that. But basically what this is saying is over 35 years, if that 50 grand is making 5% every year, that $50,000 more than quintuples, more than 5x, more than 5 times as big. It's 5.5 times as big, more than 5.5 times as big, which is crazy, right? And all that money is doing is just sitting there, not getting spent, earning interest. So it gives you a little bit of an idea of the power of exponents, right? Because they're powers. How big they can make numbers with like 5%, right? That's kind of crazy. And hopefully, we'll encourage you when you do get a job eventually after high school, that sort of thing, to start putting a little bit of money in to some sort of retirement fund when it, makes sense with your finances. Okay, let's look at a couple more problems here. So let's look at problem 2, problem 3, and that'll be it for the video. So problem 2, we just have an equation and we are asked to find the initial amount and the growth rate. So I have y equals 1,800 times 1.075 to the t. So the initial amount, sorry about the loud noises, the initial amount is the number that's multiplied in front of the parentheses. It's that first number. So here the initial amount is 1,800. Got it. It's also asking for the growth rate. The growth rate is the rate as a decimal number right here. So what I do is I know the stuff inside the parentheses is 1 plus r, where r is that rate. I'm going to take this 1.075. I'm going to subtract 1 from it to get rid of that 1. That gives me 0.075. And that tells me r equals 0.075 as a decimal number. Now if I want it as a percent, I take this 0.075 and I multiply it by 100 to get 7.5%. So either answer works. It depends, is it asking for r as a decimal number, or is it asking for r as a percentage number? All right, so that's that second problem. All right, third problem. We are asked about, well, we have a situation here. Not like a bad situation, just a contextual problem. We have the population of Descartes Town. Slogan is, I think, therefore I am here. Because, Rene Descartes. So the population of Descartes Town was 300,000 people in 2007. The population grows by 6.5% each year. What is the population in 2025? So first thing we're going to do is we're going to write the equation, and then we're going to say what's population in 2025. So we're going to say y equals initial amount. Initial amount here is 300,000. It's a number of people. Times 1 plus something to the t. It's growing at 6.5%. So what I'm going to do is I'm just going to go 6.5 divided by 100 That's 0.065. Now, this seems kind of silly to write. So I can just add 1 and 0.065 to get 1.065 to the t. So that's my equation, but the question's asking, what's population going to be in 2025? So I say, all right, 2025 is the year that I want. It started, this number came from 2007. So I say, all right, how long from 2007 to 2025? Well, it's going to be, what, 18 years? Yep, 18 and 7 will give me 25. And that means we have 18 for the t value. So I go 300,000, y equals, times 1.065 to the 18. And that gives me about, where's my calculator? Let's see. Times 1.065 to the 18, about 96 people. So almost a million. In Descartes town. Okay, so that's that. Basically here, the big idea that I want you to take away from this video is when you're given some sort of exponential growth problem, identify the initial amount and the rate of growth. The rate of growth is often going to be given to you as a percentage. So what you're going to do is you're going to go y equals whatever the starting amount or initial amount is times 1 plus whatever this percent number is divided by 100 to turn it into a decimal. You can add those two numbers together like we did here. And then don't forget about the exponent, to the t. If you put an x there, that's fine. If you're doing this on a computer though, like the computer software, if you put an x instead of a t, they might mark you wrong. Don't worry about it. Just put a t instead. Right, to get that equation, and then identify like how much time has passed to figure out what number you put in for t. Okay, that's it. Hopefully this video helps. Good luck on the homework. Find me in office hours if you have more questions.